Hey guys, welcome to the Cell Doctor YouTube channel. In today's video I'm going to continue reviving the cells. I will say repairing the battery that we started disassembling last live session. So I got the results for the testing, and let's take a look of that. So I went and disassembled the other cells as well from another battery to fill in all the slots on the mega cell charger. If you remember the last video, we had 12 cells, 12 lithium phosphate, 32 700 cells into those batteries. So I wanted to get all 16 tested, so I have enough cells to build a new pack with the same specs. So we can have a look and see what happened. You can see that all the cells, just two of them got under 6,000 milliamps. This one, which is obviously a broken cell because it cannot hold at least 90% of the capacity. This one, that's 5,915. It's still a usable cell. I will not use it in a pack if I have other cells. If there are leftovers, if these are the only cells I will have, I could still use that. I will choose to install this pack on something that's not going to create too many cycles, something like an UPS. You can use that because the UPS will stay on the battery for a few minutes and then it will charge them back. So let's print the labels. Let me switch to the label printer really fast. All right. So I will show you what I'm doing to print the labels. I click on the function and choose to print. And if the printer is set up and is connected, and my case is not connected because I connected these webcams, let me plug in it really quick. Alright, so now it's printing the labels, and the light is a bit bright to see what's there, but I will show it in a second what information we get on these labels. You can see that it prints some black labels because the printer had something in queue, and I was connected with remote desktop. That's an issue from the Dymo printer driver. It's doing some black things. So I had the auto print on, but the printer was not connected, and that's why it printed more labels now. So let me see where it starts from. 34.2, yeah, this is the place where it printed the new labels from. So we have 16 labels, and I will show you now what information you get in here. So at the top you'll see a serial number 0019. That's the serial number of the cell. Then you see the E, that's the internal resistance measured with Ohm's law. It's not the same when you measure it with an AC ESR tester, but it still gives you a value to know what to compare it with the other cells. So you see, I ended up discharging it to 2.5 volts because 2 volts was too far for these cells. The 3.3 is the store voltage. That's what we charge them for storage. And 3.7 is the maximum voltage. Once it reaches 3.7 during charging, it will stop. And next to that, to the serial number, up there you see the C dash, and that's the capacity. For cell 1, it's 6009 milliamps. Alright, at the bottom you will see MC dash, not dash, it's double quotes, double dots. I don't know. So you have 34, that's the end of the IP, and dash now 2, it's the actual cell number. So I'm going to place these labels on the cells now. I removed these cells, and now I will show you my process of building a pack using the new cells. The new tested cells, I should say. Okay, so I will end up having 15 cells. And you can do this inside the software as well. Right here you have the cells that are available, these ones, and then you can put 4 in series, 3 in parallel, and then you use available 0. Why do you say that? Available, available. Mark available. Let's try again. I'll have to look this problem up, see what what is the issue, why is not. I want 4 in series, 3 in parallel. Total cell 32, use cells, filter cells, available cells, bad cells. All available project. Yeah, it might be a bug that we'll have to check and fix. But I'm usually not using the pack creator. I created my own app because I will show you why in a second. Programming. In order to use the pack from the MegaCell monitor, you must create projects and put your cells in different boxes with those projects in order to know where to get those from, to get the cells that you are going to use. Inside pack creation, it's showing a bit different. Let me change the desktop, because this is a 4K monitor and it looks like there must be some issues with scaling the device, so I will add a new scene. Alright, so video capture. Okay, so let's move to this monitor. You should see the packer better now. Okay, so I was saying that you have to create a project and store those cells in the project so you know where to retrieve those from. I'm going to test it more in the future, see what's wrong with not being able to use it at the moment. Maybe I did not use it because Martin implemented this version of Packer, and to be honest, I did not get the chance so far to test it. And I will show you my process of using my Packer, because you can choose the cells that you want to test. So I'll have to plug in the scanner. Let me show you to this camera. I'm using this scanner. This is a rather expensive one, but we have others that are less expensive on the website as well. So this will act like a keyboard device on your computer. You have to set it properly so it gets recognized. Let me show you how to test that everything works fine before going to the software. So you get the QR code, you scan it, and you should see this kind of data and then an enter. You see that it it pressed enter automatically. This will help you add these cells very quick in the software. So here I have the pack creation. You can use this software to generate labels as well, and have a database. It's an open source software that you can use, and also if you have some Python knowledge, you can customize it the way you want it. Include different printers or add other features that you might want to have. So I'm scanning all the cells now. Okay. I scanned 2 times and it detected that it's already in there. So what I'm doing now, it's the same thing. I'm going to have 4 series with 3 in parallel. And when I calculate, it will generate the strings I will have to use. So when I scan now, I click here to check the position. Let me see where I'm going to place these. And because I have only 4 strings, it will be easy for me to just place on the table without any things. But when you build a larger pack, yeah, sorry about that. I have a client that's writing me now. It's a client that writes me now on the website. Okay. So I click here and I scan it, and it will tell me the position right here. So that's the position where I should place the cell in the string. It's the number of the string that I should place the cell on. This one in string 1 as well. 1, 3. So when you get a dash like that, that cell is not going to be placed anywhere. String number 4, 2, 4, 2, 3, not 4, 2, 3. Okay, so I ended up having 4 strings of 3 cells each. And what this software does is match the strings by capacity, so they will be as close as possible to the capacity. Alright, this I'll show the other webcam in a second. Alright, so this is the pack I ended up with. And now I'm going to open another battery and use that as a template for welding it back together, because I want to make it the same. I could make my own connection style, but I will prefer using the same because it will also match the BMS, the way they connected the BMS with the wires. So I could check the previous video because I have it there as well, but I still have to repair these batteries, so I can just open it now. All right, let me get here. Okay, so it's nothing fancy actually. It's one string up, one string down. Connected in parallel, and then each string is connected like this. Then it runs tabs to the BMS here. I see they actually spot welded these to the PCB. I'll choose not to do that because if this cell will require to be serviced in the future, it will be easier to just desolder the wires. Okay, so let me remove this as well. Spot welding is good, but makes it difficult to service it later, especially if it's not a high current battery like this is. Okay, so we have squares on top and this pattern here. Let me arrange my cells like this. I'm going to use some double-sided tape to hold them together. This will create a bit of spacing between the cells, and because I don't have that kind of wrap that it has been used to wrap the cells, I'm going to use some Kapton tape to patch some of the cells with missing with missing isolator like this one. putting cells in a pack with missing isolation part can be dangerous if they touch together during usage, and they are connected in some way that this will create a short circuit with another cell. So let's place a bit on top here as well. The best way is to find the shrink wrap that is good for your cells. So let me keep patching these as well. Alright, the rest are small. And I will also place some of the double-sided tape. Alright, so and this is how I messed it up. I will have to run this software again to check in which string I should place the cells. 1, 2, 3, 1, 3, 4, 3, 1, 2, 4. Okay, so a quick fix to rearrange the cells the way they had to be, because when I isolated them, I moved them around. Well, let me switch the camera now. Okay, so I will start with string 1. Okay. For the ones that you connect in parallel, it doesn't matter if they touch, and they are not isolated because they are connected together anyway. Okay, I'll do this like this. Now it's going to get a bit loud because I'm going to start the air compressor to use the spot welder. If you want to, you can use some glue to keep them together, but I prefer using the double-sided tape because it's going to make life easier in case you want to service this later, or if you are building a pack just for testing purposes and you want to see how it handles the capacity you want. Make sure you don't do the gluing permanently. And once you put the shrink wrap on it and also weld it in place, it's going to be standing in place, not going to move around like it is right now. So I'm thinking to make a giveaway for mega cell chargers. In the next video I will post the rules for the giveaway. I'm going to make a video just about that. So if you want to stay in tune with this kind of things, if you want to earn a mega cell charger in such a giveaway, you can subscribe and I will notify you when a new video comes out. And the giveaway will be based on some questions that I ask during my videos. So you should be in tune with the channel, knowing what videos I updated and what things we discussed about. It will be a question related to that video. I'm not going to ask you questions about math or I don't know, other similar things. Okay, so this is the pack. It is staying together quite well. Now that I have all the cells connected, I can move ahead and use the spot welder. Let me focus here. And because I'm using a thinner nickel strip, I'm going to test on a dead cell first. Let me quickly check if I have the cells clean. Actually, before moving to soldering this to spot welding the cells, I'm going to grind them a bit. I leave this process for the end to make sure that I'm doing it on the cells I will be using in a pack, because if I have bad cells, then this will be a waste of time. So I'm using this kind of end on the tool. You can find it in Dremel kits. Okay, the reason I'm doing this step is to clean up the surface where the nickel will make contact with the cell, so it stays flat during spot welding. If it's not flat, it will make massive sparks and burn the nickel when you're trying to weld it. So it takes a minute or two, but it will make your life easier when you're spot welding. So before I'm trying to do any welding on the pack that I'm going to create, I will test on a few bad cells because I had the spot welder with different settings. It was for thicker nickel, and this will probably burn through this. And on this particular welder I have three settings: BY, WT and WY, and usually it's before current. It's the intensity of the current that's placed at the tips of the spot welder before touching the cell. Then you have the weld time, that's 0.3, and then you have the WV, which is the current that's getting applied to the cell after it touched. So this will create a curve from the point it touched the cells to the point it gets welded. The welding time ends. So I will get a strip and test it on a cell right here. And before I can use this, I must connect it to air. Right. Make sure you have a flat surface where you're trying to weld, and let's see what happens with these settings right here. Not sure if you can see. It welded it fine, it did not went through, but I want to test it with a lighter setting. A few dots lower, I should say. So instead of 27, I'm going with 25. Instead of 34, going with 30. Let's see what this does. Now where it makes contact, it's a solid weld. I'm going with 26 and 31 on the final cells. Okay. So I will need 4 strips now. Depending how you're using the pack and how much current you're drawing from it, you can use thicker nickel or not, or the thin one. The thin one is very easy to weld, even with the DIY spot welders. So let's see how this goes here. Yeah, I get a solid weld. I can move on with the others. While you're welding, the electrodes will get hotter, and you might have to adjust the settings. Hallå? Bună ziua! Okay. So welded the top, and I have to make the square in the middle now. I'm going to place a middle one as well. Okay, so this is how it looks for the top part. And I will continue with the bottom one. I will flip my template around like this. I'll flip it like this. Okay, so this is the pack now. We should have 12 volts roughly if we measure 12 and something. Yeah, it's 13 volts, which is perfect. Now I'll have to run the connection for the BMS. Looking at the other BMS, starts with minus here, 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 and here, and here. Okay. Let me apply some isolating cardboard first. Okay. This is the BMS that I'm going to place back. I'm going to cut the extra bits of nickel from there, and I will weld on top. I'm not trying to remove the nickel because it's spot welded and it will probably damage the pads of the PCB, and I'm not in the mood of repairing pads. Alright, so this is the position, and the first one will get right at B minus. Second. Okay, so I finished with the spot welding. I'm going to move with soldering now. And I will have this right here. I will check that all the tabs reach the required areas. I see this actually got spot welded to the solder on the pads. So it's not the pads of the PCB, so I'm able to hit and remove these pads without issues. So this is what I'm left with. The spot welded joints got removed actually. Okay, so now if we did a good job with this BMS, we should have 12 volts right here. Let me get my... Actually 13 volts, not 12. If the BMS is not broken, but I don't think it is. And sometimes it's going to require a charging applied to the cell, to the BMS, so it actually turns on. So let me get on my power supply. I'll set it to 13.5. This is plus, B plus. Okay, so this BMS looks like it's not working because it's not getting any current. Power plus and power minus. Let's see if the other one actually eats any power. The other one looks like it's working, so I will choose to replace it with the other BMS. This time I will also count for the which tabs I solder first. I will start with B minus and work my way up, because that's the regular way of connecting of a BMS. That should not damage the BMS. It could just make it go in protection, but when you start charging that battery, it should work. Another thing that might happen with these BMSs is that they are managed BMSs, and once the battery is declared as broken, the cell got under voltage or something like this, is going to become unusable until you reset it. And to reset it, you have to connect to it and communicate with it to reset the flags, which is not impossible to do, but it depends on how many batteries you have to do. If you have a few hundreds, then it makes sense to do it. 4.465. Okay, let's see again. Still no proper voltage, but let's see if it's opening. All right, let me show you. So now that I connected the new BMS, you can see the power supply. It's getting into current protection. It's actually drawing power, and now the BMS should be open, and I can check with the multimeter that I have voltage at the leads of the BMS. And you can see that the BMS opened. It was closed because when you remove the cells, it will get into a protection mode. It detects that that cell is under voltage, gets into protection, and it will reset usually when you're applying power to it. And it detects all the cells properly. So the other one is not locked. It's probably a broken IC or other issues with the MOSFETs or something like that. So I see that the other technician or not. I see it has this kind of connection. Maybe this one goes on the actual device, and this one goes at the power for charging. Not entirely sure, but I will leave it like this. Place it in the box. Place a few more cardboard isolators here. Okay, so this is it. I'm going to place it now in its original box. Okay. Now the final step with the shrink wrap, placing shrink wrap on it. You can also place it on the battery as well, but I skipped that part. To avoid ruining the shrink wrap, you set the gun to 200 degrees, and this will prevent from making holes into the pack, into the shrink wrap. And this is it. This is the completed pack. We will place a sticker on it, but before I'm going to deliver this battery, I'm going to fully charge it and discharging using my bench load to check that everything works fine, and I can trust this kind of process for fixing the batteries. So I will do this off camera because it's going to take a few hours, maybe a day, to fully charge and discharge this battery at a 1 amp rate. If it's almost 18 amps hour, it will be about 18 hours to charge and discharge at the same rate. So that's the process you would follow to rebuild a battery with cells that you got from similar batteries. I could have made the capacity higher. Instead of placing 3 cells in parallel, I could have got to 4 cells, and that would have made a 24 amp hour battery. But I wanted to make it to the same spec the battery was. I got it working. It works fine. I found out that the BMS was broken on the other one. This may be the issue that led for that battery not be usable anymore. And on another battery, you could have a bad cell, but you never know. That's why you need to test the cells, and to test the cells properly, I developed the mega cell charger. Me and my team worked on this for 4 years now. Now we're getting the new version out soon, the professional version that's going to be more capable in terms of features and ways of testing batteries, supporting multiple chemistries, and a few more other advancements that we thought on implementing on that board for better measurement of these cells. So use a proper capacity tester. If you don't have one and you want a mega cell charger, go to deepcyclepower.com. You can go on the pre-order for the professional version. That's going to be available for another couple of days until I get the prototype back from the factory, and after that we're going to place the order for the devices that we have in pre-order. We might be having pre-orders in the future. I'm not sure. I will probably choose to make a stock and sell it from stock, depending on the demand that we have. If it's a low demand, then we'll have a pre-order. If demand gets higher, we will ship it from stock at a higher price. Right now you can get it with 197 euros. In the future it will be more than 280 euros for same device. That's because we are constantly working on software improvements. The hardware got a few improvements as well. That adds to the cost of production. So if you're into batteries and if you want to build batteries, you can also make a business out of this. There are a lot of recycling companies that are doing it already, or there are DIYers. Like this could be a DIY project to get in touch with a local supplier of a device that has battery in it, e-scooters, you name it. This kind of solar chargers, solar generators and stuff like this, they have batteries, and they have multi-cell batteries that you can service for them. You will do them a favor and to the environment as well, because the other option for them is to buy these packs directly from the supplier, and all the other cells get thrown to the garbage. A lot of them will stay there for years, and they will become unusable, because if they get rusted, they get damaged physically, you cannot reuse that cell. But if they come from packs, enclosed packs like this, you have usually 80 to 90% of the cells that are still reusable, especially when it comes from a new pack. This one is a 1-year-old pack, so you don't have it. They probably have a few cycles on the cells. You saw that the capacity was up there from on the specs. Usually you'll see a degradation when they have multiple cycles on those cells. Instead of 6,000 milliamps, you will see it at around 5,800, 5,700, or like that cell which got broken, which can be a defective cell from the factory. It had an issue with the way it wrapped the copper inside it and all that, and it created a bad cell. And if they did not measure the capacity of each cell like we're doing it when rebuilding the pack, they might have missed it and produced a bad pack. That's common, because they have a big big demand on creating those batteries, so they cannot spend the time to fully test each cell that's going into the pack. They are testing the voltage and the AC reading for the internal resistance. That's what they do automatically, but cycling the cells up and down takes time, and they cannot do it easily, at least for all the cells. Maybe they are doing it for larger packs, matching the capacity and the ESR, but for smaller packs they probably are not doing it, and you will end up having some devices with bad cell in them, works for a few cycles, and then gets wasted. So that's that's it for this video, guys. If you have any questions, don't hesitate to comment on this video. If you want to know more about the mega cell charger, you can check my other videos that I posted about this device, and you can also go to the deepcyclepower.com, go to the documentation section and choose the mega cell charger. You'll see the PDF documentation, the YouTube videos I made, and also you can chat with me directly using the chat from the website. That's it for today, guys. Thank you very much for watching. It was a long video, but this is the process of doing it, at least the first time, because this pack was new for me. I never used this kind of cells before. I don't have all the cell holders and all the equipment I would have for building the packs for this. So mostly is the cell holders, because that helps you keep the cells in place. For the bars, the nickel strips, usually cut multiple of them in the size that you need, and then you put that when you're making series. And I will probably have multiple of these to repair, or I might teach the company that got these batteries, that I got these batteries from, how to repair them, and this will lower a bit the demand of new cells, and pause a few cycles, it will prolong the life of these cells for another few years, instead of getting them thrown to the garbage. Again, that's it for today, guys. If you're not a subscriber, please subscribe to this channel and share the video wherever you feel it's relevant, on Facebook groups, on forums maybe. Get this information spread out, because I believe it's valuable information to know that these batteries can be reconditioned, repurposed, or create the same type of pack you got the cells from. When I'm saying repurpose, I think on getting a new pack. Most of the users are building power walls, so you will get like 100 of these packs, test them, and make a big battery bank that you can charge with solar power. Make it higher voltage. Instead of 12 volts, you get usually to 48 volts, or even 67 volts, that you can use for solar power, and you get cheap batteries. Because if people don't know that they can reuse these batteries, if you're going to a supplier that has broken batteries, it's work for them, and they don't have a process in place for testing those batteries, and there's no value for them in those batteries, and they will sell them cheap. Some of them will give them as free if you don't show too much interest in them. If you're going, I need this, I want to build this, then you will tell them that you actually give value to these batteries. If you go, I'm doing some test, I want to check some batteries, can you give me 50 of them? And maybe you give them I don't know, about $5 to $10 on such battery. Their actual value will be, such a cell, I checked around, and it's 10 euros per cell. So you could pay easily €1 per cell, or less, 50 cents per cell. That's a good deal for this kind of cells. Even if you are getting broken cells, you still get a good value, because these are high capacity. They have 6,000 milliamps. They are lithium phosphate. They support multiple cycles, more cycles than you will get on lithium ion. So these can get up to 4,000 cycles, depending on the manufacturer. These were posted for 2,000 cycles, which is still twice as much as most of the lithium ion batteries will get. They get mostly from 800 to 1,000 cycles, which is still a lot if you're considering it. but you still get more cycles on lithium phosphate. You don't have the same power density on the same, yeah, the same power density for a pack. You will get a larger pack with the same power, but if you don't have a problem with space, you should not have an issue between choosing lithium phosphate from lithium ion. So again, that's it guys for this video. Thank you very much for watching. Don't forget to subscribe, like this video if you think this content is relevant to you, and also post a comment about your thoughts. Maybe you want to see some future videos, you want to see how I'm repairing other types of batteries. Type in the comments and I will think about it. Have a great day guys, and happy charging and discharging.